Hey guys, welcome to section 6.5. Today we are looking at putting all of the transformations together with our trig functions. A few formulas and things to refresh our memory before we get started. First of all, the equation of the axis. You can take your maximum and add it to your minimum. This is the value at the peak and the value at the trough. Add them, divide by 2. That's the equation of the axis. If you hadn't realized yet, this value is our C value. And I think we gave it the value of Q, the letter Q, when we did it. I couldn't care less what letters you call them, depending on which book you go to, which source. Sometimes they'll switch back from one to the other. Okay. The amplitude is the height of your curve. You can take the max, subtract the min, divide by 2 to get the height. And if we're looking at our equation, our amplitude is the A value. So that one we can just look in. The period of the function would be the distance of a cycle. And in order to find that, we're going to take 360 degrees. And there it is, the 360 degrees, and we're going to divide by this. We only worry about the positive value, which is why we have the absolute value signs around the K. If it's negative, ignore the negative. All that's going to do is just reflect it, and we don't want to deal with that right now. Okay. And then the other thing, which you haven't seen yet this chapter, but you did see earlier in the year, I had introduced you to a mapping rule. You are welcome to curve sketch using the mapping rule. If you have an X and a Y coordinate, remember X over K plus D, and then the Y coordinate becomes A times Y plus C, where your A is the number out in front, the C value is the one that gets added at the back, the K and the D are the values inside your function, the D is the horizontal shift or translation, and the K value is the horizontal compression or stretch. Okay? All right, so if I have to refer back up there later, we will. I don't care which way you do it. I'm going to talk using the, I'll show one example with the mapping rule and then one with the curve sketching, okay? So we can graph any of these by using our curve sketching. So let's quickly look at this one right here, and then we'll answer some questions below. So let's see, this is my A value. So that is my vertical stretch. This is my K value. So this is a horizontal compression. This means I will move to the right 60 degrees. So this is right 60. And this is going to shift it up 3. Now, I know I keep mentioning, I'm like, I do it backwards. I don't do it in the order or the way that we're supposed to do it in math. I like switching my axes first. So if this is my axis, oops, what happened? There we go. So if this is where my axis should be, I notice that it's going to go up 3 units. So I'm just going to put a yellow dotted line there for myself. And then I notice that it's been shifted to the right 90, to the right 60. So 60 would probably be somewhere over here, okay? All right, so now I'm going to get my tools. There's my pen. Okay, so they've already drawn the sine curve for us. We can stretch it or we can use our axes. So this is stretched by 2. So instead of it 90 being an amplitude of 1, it would be an amplitude of 2. So I'm going to use my main points again. And you should get a much larger graph. Now I'm going to compress it by a factor of 1/2. So if it was at 90, now it'll be at 45. If it was at 80, it'll be 90. If it was at 270, it'll be in here at 115, rough day, 135. And then 360 would be at 180. So I'm going to put this as just a few dots. You should get a curve, something like this. And this is just our stretch and our compression, our vertical stretch and our horizontal compression. Now we need to move those dots right 60 degrees and up 30. So let's do a different pen. There we go. So I'm going to take my main points. I'm going to move it right 60, which is about here, and up 3. Whoops, 1, 2, 3. So it's about here, okay? Which would be where we estimated our new axes to be. This point over here at 90, if I go over 60 and up 3, 1, 2, 3. And then this one over here at 180, 80 plus 60 would be around here, and up 3 degrees would be here. Okay, now take the peak and the trough, your max and your min values. This would be right here at 45. 45 plus 60 is 105. I would be somewhere around here. And then I'm going to go up 3. 1, 2, 3, right in the middle. And this guy would be over 60 degrees, which would land me about here, and up 3. 1, 2, 3. Okay. And if you see my kind of yellow axes, my new graph, let me just do this one here in red. You should see that this red graph looks really similar to the black one, but its starting point, like these yellow axes, would be paralleled, or I guess similar to the original axes that we had. Okay, so anyway, there is your curve sketching. Do your horizontal compressions and stretches first, and then shift it over, and you get this beautiful curve. Okay, and we've got all of our information from here up in our curve. Okay, so let's scroll down a bit, and we can just make sure that we have all the right information. So the amplitude, we can get it from here. It should have an amplitude of 2, and if you look at your new axis up to the highest point, or your equation of the axis up to the highest point, it does in fact have an amplitude of 2. The period went from whatever this number was to whatever this number was. It's actually easier to see on the black graph. It went to 180 degrees. So the period is 180. Now remember, the period you can get by taking 360 and dividing by the K value. 360 divided by 2 is 180. So my period is, the period for the function is good. The phase shift is how much we have moved left and right. We have moved right 60 degrees, 60 degrees. And the vertical displacement, we went up 3 units. Okay, so 3 up. Our range would be all of the Y values from 1 to 5. So hopefully you remember how to write that. So Y is an element of the real number system such that Y must be greater than or equal to 1, but less than or equal to 5. And then you close those off in brace brackets. And then the equation of the axis, take your maximum, add your minimum. So 5 plus 1 is 6, divide by 2, you get 3. And our equation was at 3, so that's good. Okay. All right, so we have got all the information for our new function. Okay, I want to do a super quick, just kind of get a super quick version of the mapping rule. So hopefully just a quick refresher before we move on. X over K plus D, so all of your horizontal stuff goes together, and AY plus C, all of your vertical stuff goes together. Okay, so let's look at this graph right here. Okay, so looking at this new information, you should notice right away there's a big, whoops, there's a big warning here. There is a number beside our X and there's no brackets in between. So you have to factor. So the first thing we are going to do is factor this. I'm going to put another set of brackets, brackets here. And when I factor and I take 0.5 out, I'm also going to take 0.5 out of the 30 degrees. But if I take 30 divided by a half, I should get 60. Okay? Oops, what happened? Okay, so factor out a half, you should get X plus 60 degrees remaining in the brackets. Now that we've got all of that, now we can start using our mapping rule to help us out. As for our mapping rule, I'm going to try and use the pen tool. I know it gets pretty messy. I apologize ahead of time. So we have got our X and our Y values. Use the main points. We are graphing coasts. So on our X axis, we would have 0, 90, think about your unit circle, 180, 270, and 360. Okay, now when we're plugging them into the mapping rule, your new X value is going to be X over K plus D. And then our Y values are going to be AY plus C. Okay, so let's identify. This A value is -2. This 0.5 is K. Now remember, this is even though it says plus 60, this is a minus 60. So the minus 60 is going to be our D value, and the 3 over here is going to be our C value, okay? So we're going to take each one of these, we're going to replace the K and the D and the A and the Y, and we're going to come up with our new values. Before I do that though, actually that's okay. Let's look at our X coordinates. So I'm going to take 0, I'm going to divide by 0.5, and then I'm going to add 60. That should give us 60. Actually, let's erase. So now that I know my K value, let me just replace those terms with my actual numbers. So this is going to be X over K, but K is 0.5. And then I need to add my D value, which is 60. Okay, so now I'm going to take 90 and I'm going to plug it in here. 90 divided by 1/2 is 180. 180 plus 60 is 240. Now I'm going to take the next one. 180 divided by 2, divided by 1/2 is 360. 360 plus 60 is 420. And then you can continue on. Okay, I'm just going to stop there. Let's look at the Y values. Actually, why don't you take a second, pause the video, and then finish up those values, and we'll do that kind of right now. Okay, so I love checking my work because I tend to make mistakes, and I guess it's good that we see mistakes so we can correct them. If my D value is -60, which I probably should have made a little bit more clear to myself, this should be -60, which would put this at -60. That would change this value to 120 and this one to 300. So let's erase these bad numbers. There we go. For those of you that noticed it, thank you. I'm glad you noticed it. I hope you didn't get too confused. There we go. So 60, this should be 120, 300, 270 times 2 is 540, minus 60 is 480, and then this last one, 360 times 2 is 720, minus 60 should be 660. Okay, all right, so those are your X values. For the Y values, your original function, your 5 main points for cosine would be 1, 0, -1, 0, and +1. Take your Y value, so take this 1, substitute it in here. My A value is -2, so again, now I'm going to plug these in, so AY plus C. My A is -2, so -2 times whatever my Y value was, and then plus C, which is 3. So 1 times -2 plus 3, you should get 1. 0 times -2 plus 3 is 3. -1 times -2 plus 3 is 5. And then 3 and 1 again. Okay? Now that you've got your new points, you can simply just graph them on. So -60 would be about here, -60 and 1. I have a value there. At 120, which is here, and 3, I have another point here. 305, because these are my coordinates, 305. 180, oh sorry, 480 is over here, and 3. And then 660 and 1. And 1, there you go, okay? And here is the cosine curve that has been vertically reflected, vertically stretched, horizontally stretched, shifted to the left 60 degrees, and shifted upwards by 3 units. Okay? You can fill in the bottom information on your own. There's one last thing I would like to do with you, and it's just coming up with an equation given some information. If your amplitude is 3, that's your A value. If the period is 120, remember, to get the period, you go 360 degrees divided by K would give you 120. So simply take 360 degrees and divide by 120 to get the K value. So in this case, K would be 3, because 360 divided by 120 gives us 3. The phase shift to the right means that our D value is going to be 60. The equation of the axis, that means our C value that we add at the end is going to be -2. And the graph starting at a minimum, to be honest, don't worry about for now. So they do want us to use a cosine function. So y equals, let's just put cos of, I'm going to say cos of x. My theta sign will take me a while to get in. So my a value is 3. I do have a k value of 3, but it's also shifted to the right. So you know what? I'm going to put a set of brackets here and here, and it's shifted to the right. So we're going to go -60 degrees and close our brackets. And then this will be shifted 2 units up, so -2, because that's on the outside of the brackets. And voila, you've come up with your equation for a translated or transformed trig function. Okay, guys, that is it. You've done great, and we'll see you for the next section.